A warm welcome to all the viewers. In this session, we are going to see how we can easily check the fairness of a dice or a coin toss. You must have experienced while playing with the dice or tossing a coin that what is the probability of getting heads or tails, or what is the probability of getting a certain number on a dice. It is quite interesting to know that you can easily and manually do the calculation via a simple statistical measure which is known as chi-square goodness of fit. The principle behind chi-square goodness of fit states that the observed frequencies match with the expected frequencies or they do not match. So that is the essence of this test. How it is carried out? Let us see. Goodness of fit is a statistical technique which compares the observed frequencies, that is what you actually got, with the expected frequencies, that is what you would expect by chance, to check if the data fits a specific distribution. Now, imagine you are playing with a dice and you have thrown the dice 60 times. So, what is the probability? That is, what is the chance of getting a particular number on the dice? We all know that a dice has 1 to 6. There are 6 numbers, there are 6 sides to a dice, right? Ranging from 1 to 6. So, if I say, what is the probability that you will get 1? So, that is 1 by 6, right? Because the probability of getting any of the numbers on the dice is 1 by 6. Out of the 6 options on the dice, we will get the one option 1 by 6 times. Any one option will get it 1 by 6 times. So that is known as probability. If I talk about expected frequency, it means if you throw a dice for a certain number of times, say you threw it 10 times, how many times would you get that number? Now we need to calculate the expected frequency first before we go on to the comparison and calculation of chi-square calculated value with the chi-square table value to determine whether our dice is fair or not. Similarly, if you have a coin, you have heads and tails on a coin. So then the probability of getting heads is 1 by 2. That is zero point 0.5, right? Because there are two sides. Similarly, for a dice, the probability of getting any of these numbers is 1 by 6. You multiply it with the number of times the dice is thrown to get the expected frequency. So in case we are looking in for number 1 on a dice and we have thrown the dice 60 times, herein we are provided with a table which tells us the observed frequencies of the different numbers 1 to 6 on the face of a dice. So out of those 60 times, we saw that 8 times 1 was there, 9 times 2 was appearing, 10 times 3 was appearing, 11 times 4 was appearing, 12 times 5 was appearing, and 10 times 6 had appeared. That makes a total of 60. So in this we see the null hypothesis stated by us is the dice is fair, all faces are equal likely. Alternative hypothesis framed by us is the dice is not fair. Faces are not equally likely to appear, right? In other words, we can say that the null hypothesis states that there is no difference between the observed and expected frequencies. And here we have the observed frequencies. Let us now check it out how to take out the expected frequencies. For a fair dice, each phase has equal probability, that is 1 by 6. Total throws are 60. Expected is, as I told you, 1 by 6 multiplied by 60 gives us 10. Now, we are going to find out the chi-square statistic. So, we see here that the expected frequency is 10 for any of the faces ranging from 1 to 6, because it can appear 1 by 6 into 60 times, that is 10 is the expected frequency, right? So we use this chi-square statistic formula to put in the values wherein O stands for observed frequencies, E stands for expected. So once we have calculated O minus E square for all the faces, we are going to divide it by the expected frequency. And once we divide it by expected frequency, we are going to sum up all these face values and that will come out to be a total of 1. You see here, We summed up all these and that came out to be a value of 1. Now we calculate the degrees of freedom. As the dice has 6 faces, in that case degrees of freedom is calculated as n minus 1, that is 6 minus 1 is equal to 5. At 5% significance level and degrees of freedom 5, the chi-square statistical critical value is 11.07. We saw it from the table. Let me show you where is it present in the table. So this is the chi-square table of critical values, wherein you see at 0.05 significance level and 5 degrees of freedom, you have the value which is 11.070, right? So we have to compare this value against the calculated chi-square value in our case. In case the chi-square calculated value is more than this, then we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Since the calculated chi-square value is less than the critical value, as the chi-square calculated value came out to be 1, which is less than 11.07, the table critical value. Hence, we fail to reject the null hypothesis. So, that means the dice can be considered to be fair. I hope you enjoyed this video and you will definitely share it with your friends and faculty colleagues. And next time you play with a dice or you toss a coin, definitely use this statistical measure and flaunt it to your friends. Thanks a lot.